All right, let's talk about the AI that is suddenly everywhere. Today, we're going to pull back the curtain and really look at the secret engine that's powering these incredible tools like ChatGPT. I mean, think about it. You type a question and boom, almost instantly, you get back this incredibly detailed, coherent answer. It really does feel like magic, doesn't it? But how does it actually work? How does it get the nuance, the context, the real meaning behind what you're asking?
Well, the good news is it's not some kind of dark magic. You can trace this entire modern AI revolution all the way back to one single powerful and, honestly, pretty understandable idea. So let's break it down.
First things first, let's get our bearings. All these amazing AI tools that seem to have popped up out of nowhere, turns out they all share the same technological DNA. Yup, whether you're using ChatGPT, or you're on Google's Gemma, or maybe Meta's Llama, you're basically interacting with a system built on the exact same foundation. They're all part of the same family, and today we're going to learn the family secret. Now, to really get why this new architecture was such a huge deal, we first need to understand the problem it solved. See, for years, AI had this fundamental issue when it came to language. It had a really, really bad memory. The older models, they used to process language one single word at a time. Just imagine trying to read a long, complicated sentence that way. By the time you get to the end, you've probably forgotten the important stuff from the beginning, right? Well, that was the AI's problem. The new models, though, they can see the entire sentence all at once, giving them the full picture, the full context, right from the get-go.
And this brings us to this one pivotal moment. The year is 2017. A paper gets published with this incredibly bold title, "Attention is all you need." And that paper, it didn't just suggest a little tweak. It introduced a whole new way of thinking that basically kicked off the AI explosion that we're all living through right now.
So, what was this big idea? What was the secret sauce? Well, it's a mechanism called self-attention. This, right here, is the secret engine. It's the absolute core of how modern AI understands you. So, what does self-attention actually do? Well, it gives the model the power to look at all the words in a sentence at the same time and figure out how important they are to each other. It's like it's drawing invisible lines, creating direct links between words to see how they're all related no matter how far apart they are in this sentence. Okay, I know that might sound a little abstract, so let's make it real. Let's just use a super simple sentence and see exactly how this works. Okay, so the model takes our sentence and focuses on one word. Let's say bear. Then it basically asks itself a question. To understand what bear means in this specific sentence, what other words are the most important? And instantly, it creates these strong connections. It knows that teddy and cute are super important for describing what kind of bear we're talking about, and that reading is crucial for understanding what the bear is doing. And that right there, that's the aha moment. With this self-attention trick, the AI isn't just seeing a string of words anymore. It's building a map of relationships, a whole web of meaning. It gets that teddy describes bear, and that bear is the one doing the reading. Now, this super powerful self-attention thing, it doesn't just float around on its own. It's actually the core engine inside a much larger machine. So let's see how it all fits together. And that machine is called the transformer. This is the full architecture from that 2017 paper, and it's built around self-attention to do two very specific, very important jobs. Think of the transformer like a two-part system. First up, you have the encoder. Its only job is to read your question and create this really rich, deep understanding of it using self-attention. Then it passes that understanding over to the second part, the decoder. And the decoder's job is to take that understanding and start writing, generating the answer, one word at a time. So we have the core idea, self-attention. We have the architecture, the transformer. So how in the world do we get from there to the gigantic AI models we use today? Well, the answer is just one word, scale. And that's where we get the large language model, or what you've probably heard called an LLM. Here's the key thing. Most of today's chatbots, like ChatGPT, they're basically just the decoder part of that original transformer design. They've just been scaled up to an absolutely massive size. And when we say large, what does that actually mean? Let's start with a number. We're talking about models with over 100 billion parameters. You can kind of think of a parameter as a tiny little knob that the model can turn and tune to learn all the patterns of human language. So you have these billions of little knobs, and they get tuned by feeding the model just a staggering amount of data. We're talking trillions of words from pretty much the entire internet and huge libraries of books. And all of this gets crunched by thousands of super powerful computer chips running nonstop for months on end. That's the large in large language model.
And it all comes back to this one core structure. As Stanford's Afshin Amini puts it, the transformer is the foundational architecture that makes all this work. It's the blueprint. It's the foundation for everything we see today.
So there you have it. It's kind of wild, right? You go from one ingenious idea, self-attention, in one paper in 2017, to the transformer. And then by just scaling up that transformer, you get the LLMs that are literally changing our world. It's a straight line from a single concept to a global revolution.
I mean, the journey from a simple sentence about a teddy bear to an AI that can write poetry and code, it's just astonishing. And it all started with giving a machine a new way to pay attention. It really makes you wonder, if this one idea unlocked something as complex as human language, what else is it going to help us understand next?